with this whole proof thing, what's important, again, is that you see a lot of examples. And hopefully you've been watching the podcast. When I checked earlier, it looked like about half the people had watched the podcast, which is not good. But that's one way you're going to get examples. I'm also going to be doing some examples in class, just like I did yesterday. I'm going to do again today. Now, I've got 3 examples that we're going to work through for proofs today. And you'll notice they all have exactly the same picture. But all 3 proofs are going to be different because it doesn't go with the picture. I've got a lot of people who are saying, but I can look at the picture and I can see that. That's not what matters. The picture is not what matters. It's the evidence that we're interested in. And the givens, when the givens change, the evidence changes, and we have to apply different strategies. So we could actually, after the podcast on Tuesday, do some additional different proofs with this exact same picture. There's a lot of different strategies we can use. So we're going to go over these proofs. And again, you're just going to start seeing some repetition. Oh, when I see this, then I can do this. It's going to help you be a little more consistent with them. So let's take a look. First one. Where do we start?
Givens.
Okay. I've got 2 different givens. Do I want to list them both at the same time or one at a time? One at a time is usually the best bet. As you become good at proofs, you might choose to do more than one given at a time. Okay? Just to save a teeny bit of time. But for now, let's just do one at a time because you're going to make fewer mistakes that way. It makes things a little more clear. Now, I don't have to do the givens in any particular order. I can go with the first one first and the second one second, or I could switch them up. What do you want to do? Which given you want? Oh, top one first? Okay, fantastic. There was no wrong choice there. Okay, reason? Given. Now, here's the question you're going to hear me ask all the time. So what? What does that mean? Remember, the purpose of every given is to lead us, hopefully, to some parts being congruent. And then we get enough parts built up that we can get congruent triangles. So, this given is that L is the midpoint of segment EG. Fantastic. Can I make any conclusion about parts being congruent from that statement?
Yeah.
Which ones?
Segment EL is congruent to segment GL.
Okay. EL, therefore, must be congruent to GL. Reason? Yeah, this is one we did before in the last time we did proofs. Definition of midpoint. Because that's what it means to be a midpoint. And again, this is why it's important that you know all your old definitions and stuff like that, because it just keeps coming up. Fantastic. I just got some parts congruent. I should mark that. EL is congruent to GL. Nice. All right. Now I've got some parts congruent. I go back and I look for the next given. What's my next given? EF is congruent to FG. Now I don't have to do any work to get congruent parts there. That's a free one, right? It's a freebie. Fantastic. Now I go back to my next given, but I'm all out of givens. So next thing we have to do is we have to look at the picture. What's the picture giving us? What do you got? What do you get? Yeah. We have that shared side. Reflects. Yep. Now, I have 3 pairs of corresponding parts congruent. And when I look at them, it's pretty clear which shortcut we're using, isn't it? SSS. Now I got to make sure I'm getting the congruence statement in the correct order, because everything is right here, but I got to make sure that I state the congruent triangles in the correct order. The safest way to do that is to look at what we're trying to prove here and just copy whatever order was there. Triangle GLF is congruent to triangle ELF. That's right, there is an elf watching you. It's December now.
Wait, what's the elf's name?
Right there's the elf. Hermie. Hermie.
I like that. I like Ernie. You know what I'm saying?
Hermie. From Rudolph?
The guy's name is Ernie?
Hermie.
I did not know that.
He wants to be a dentist.
Hermdog? I thought it was something else. Hermdog?
Hermie.
Hermdog.
Hermie is his name. So there you go. So there's one proof, okay? Let's look at the same picture. I'm going to go to this one first. And we're going to change up the givens a little bit. One of the givens is the same. So let's start with that one. Okay? L is the midpoint of EG. Given. Now, when I'm told something's a midpoint and I'm looking for congruent parts, what are those congruent parts? Should be pretty obvious. Same thing as last time. Yeah. And what was the same reason we used last time, which is definition of midpoint. See how we sometimes get patterns within the proof? Okay, not always is it going to work that way, but a lot of times it is. Okay? Yes, I am. That's nice. It's a fashion statement. Okay, next given is FL is perpendicular to EG. Because it's given. Okay? Now, wait, I should probably mark EL congruent to GL. There we go. Okay, what does perpendicular mean? We did this yesterday in our proof. If I have perpendicular, it means I have right angles. What are those right angles? And ELF and gulf. Okay, what's my reason? Definition of perpendicular. Now, here, the next step is where we have to make a choice. And so we're going to have to kind of look forward and plan a little bit. If I'm going to go for something like, say, side angle side, I just want those angles to be congruent. And it's really easy to say ELF is congruent to GLF because all right angles are congruent. But the other option we have is stating that those are right triangles. And we use that when we do H, we're going to use HL as our reason. So I got to kind of plan ahead a little bit at this point and say, okay, what shortcut am I going for? So look at the picture. I've got a side. I could go with these two congruent, and then we'd have another side. Would that be side angle side? Yeah, it would. Oh, so maybe that's the direction I want to go, isn't it? Okay, so I think I'm going to want to go ahead with angle ELF is congruent to angle GLF. And what's that reason again? Because our theorem 2.3 said, we did this one yesterday. It's simple. Not definition of right angles is a theorem. All right angles. Congruent. There we go. Okay. And then we have our reflexive again. So 6. FL is congruent to FL. Yes, you could. Reflexive. Okay. And then 7, finally, we have our congruent triangles. SAS is my shortcut. Now that's a 7-step proof, which seems like a whole lot up front, but again, what are we doing? We're taking it in like baby steps, right? Yeah. So it's really not that bad. Okay, one more. Okay, kind of mixing it up a little bit this time. Let's start with the second one. Okay. EF is I want my freebie first, so EF is congruent to GF. I like that because that's a freebie. Okay. Now, let's say, is it okay to notice right away I have that reflexive and just throw that in right away? Do I have to wait till after the givens to do that?
Yeah.
No. Okay. You can go ahead and throw that in now, okay? If you see this, say, I know that reflexive is in there. I know it's important. I just want to, that's quick. It's easy. The perpendicular thing is going to be more work. So let's go ahead and do that quick. You may do that if you want. Usually it's givens and then picture, but if you want to throw the picture stuff in there ahead of time, it's not wrong. So I'm going to do that this time just because it's going to make my life a little easier. It wouldn't be wrong to wait to after either, but we've done this 3 times. We know that's going to get used. Okay. Finally, I have my other given, EG is perpendicular to FL, which means what? When we say it's perpendicular, we go to, it means they form what? Right angles. So angle FLE, or ELF, we'll stick with the L, is congruent to angle GLF. Okay, and that's definition of perpendicular. Okay, now, well, I didn't say, I'm sorry, I meant to say the right angle. Sorry, I got ahead. Got a little bit excited. Not too quick. ELF and GLF are right angles. Sorry, okay. Now, what shortcut am I looking at here? It's not SAS, is it? Well, how do we know it's not SAS? Okay. The angle is not the angle that's being formed by the congruent sides, is it? So it's not SAS. This is an HL. But in order for it to be HL, we have to do one special thing. We have to state that they're right triangles, because HL requires right triangles. So we aren't going to say the angles are congruent. We're just going to say, oh, triangle ELF and triangle GLF are right triangles. And that's the definition of right triangle. And now we can use our HL. Triangle ELF is going to triangle GLF. In order to use HL, I have to somewhere in there state that they're right triangles, because HL only works with right triangles. But just because something's a right triangle doesn't mean we have to use HL, as we saw in this one. I had right triangles here, but I didn't use HL there. I used SAS. So HL becomes an option when we have right triangles, but it's not required when we have right triangles. Okay, so those are examples for today. Those are some additional examples. If you need to review them again, I'm going to put this on to Schoology and YouTube. It won't be on Edpuzzle, but that'll be out there as an additional review for you.